this example, we're trying to figure out how far a sailboat is from the lighthouse. So the first step I find is really helpful is to just model the situation. So let's just draw a picture showing the 120-foot lighthouse, that angle of elevation being 16 degrees, and labeling that distance that we're trying to find as D. So with this situation, we see our reference angle, we know the side opposite to our reference angle, and we want to find the adjacent, which tells us that we want to use tangent. With word problems, sometimes we're not sure if we're using trig or inverse trig ratios, but because we're trying to find a side length, we know we're going to use a trig ratio because we only know an angle measure of a right triangle and a side length. So we couldn't use Pythagorean theorem to help us. So let's go ahead and set up tangent and then solve for D. We're trying to solve for our variable, so we need to make sure that our variable is in the numerator. Currently, it's in the denominator right over here, so we need to multiply both sides by D in order to get D in the numerator. So let's do that. So that's going to leave us with a D times tangent of 16 degrees is equal to 121. Well, we need to isolate D over here, and in order to do that, we need to divide both sides by tangent of 16 degrees. So 121 divided by tangent of 16 degrees is approximately 422 feet. So when you are asked how far is the sailboat from the lighthouse, you should respond with something like, the sailboat is approximately 422 feet away from the lighthouse. I know that sometimes it's a little more difficult to solve when your variable is in the denominator, so I'm going to show you a way to solve this problem where D is actually in the numerator. So let's do that. So in order to do this, I can't use 16 degrees as my reference angle, so I need to figure out this angle measure right here, and that's going to give me 74 degrees. Well, if I use 74 degrees as my reference angle, then now D is the opposite and 121 is the adjacent side. So we can still use tangent, but it's just going to be set up a little differently. So in this equation, now all I need to do is multiply both sides by 121, and then I can multiply or type into my calculator 121 times tangent of 74 degrees, which is still going to give me 422 feet approximately. And there we have it. So we can solve either way. It just is a matter of personal preference. And yeah, just whatever you want to do there. So let's look at another example. In this example, we have an object that's so many meters away from a 40-meter tall cliff, and we're just trying to find the angle of elevation formed by that object. So we know that we have the angle of elevation, we have the angle of depression, and the angle of inclination. And if you didn't know that, we do have a slide here. A lot of times we accidentally use angle of inclination when we shouldn't. And sometimes we are looking for that. So I'll include this in y'all's notes as well. So when we look back here, we're looking for the angle of elevation in our picture that we're going to draw for example 2. So let's draw that picture first. So once we get our picture set up, we see that we have this reference angle down here, and we know the side lengths of the opposite and adjacent side. So we can just use tangent or tangent inverse to solve. And that's not that we're always using tangent for these kinds of problems. It just so happens that these two examples needed to use tangent or inverse tangent. And when we type this into our calculator, we're going to find that theta is approximately 34 degrees. And here's just one more graphic that may help you. So if you had a right triangle like this, here's your inclination, your angle of inclination. Down here's the angle of elevation, and over here is the angle of depression. And the angle of depression and the angle of elevation are always congruent. This is related to parallel lines. So if you know the parallel lines theorem, you could verify that for us. And that concludes these examples. So go ahead and try the other problems that we have for you.